now, AJ, we'll turn it over to you. Let's know about yourself and then starting your presentation.
Yeah, you only have, Roger and Bill have introduced themselves. Myself is AJ Menon, and I've been at Cirries for about 5 years. In the second stint, I was with them back in the early days as well. My background is telecom, Nortel, and a few others with Oracle and Sun, but big telco projects. So what we're going to talk today is about Cirries and what we're doing with edge computing with the new 5G world of an IoT. And that's what we're going to talk about. The company was founded in 2006 and basically with boutique projects. And then about 5 years ago, we moved a lot of the stuff that we've done into developing a product, and that's what we have today. So we have a full-fledged product with network performance, identifying problems in the network, and then how do we resolve issues very quickly. And we have customers worldwide, Verizon, to name a few, Verizon, Telefonica. We have Globe in the Philippines. They work with some of the equipment players as well, like Ericsson in Mexico, just to name a few of those. You know, I know you guys know the IoT market, so I won't get into it. But within the IoT and the 5G market, there's edge computing. I never knew what the heck edge computing was when IoT first came out. Then it's the fact that they want to have something in the middle between the radio and the core, where the control section is, because latency is a big deal. So how do you have robots and other devices within several industries to be able to operate in a quick manner so that there's no delay? And that's the key factor that we're dealing with. And that market is supposed to be about 600 billion by 2030. But what's interesting is that we had some conversation with Gartner, and they felt that in their assessment, 75% of enterprise customers would be moving towards edge computing here within the next 3-4 years, because they're moving away from having all their gear on premise, moving to the cloud. Where's the cloud going to be? It's pretty much on the edge and not really at the core. And I'll say this: it's a big deal even for Dell. By the way, a lot of people are buying Dell equipment for that. Okay. And as you saw the Apple announcement, AR, VR, it's a big deal. But among other things, what I'll show you some use cases coming up where, just a second, let me go back here, where we were finding the whole concept of 5G being leveraged in certain industries that I couldn't even think about. It was very fascinating, and we got some projects in those areas as well. I'll just go into that. Okay. The main thing here on this slide is Bill and I have been working on this the last 2-3 weeks, actually, with one of our partners, is latency. How do I get the latency to be really low? How fast can I get it? So when you talk to AT&T, they're moving the COs away from what their COs are today to be housing edge computing servers within them, so they're as close to the radio side as possible to their customers. So the COs are being converted from what they are today to move into in that direction, and that's really becoming a big thing. And I found that out. And AT&T, for example, is working even with the U.S. military and with these aspects as well. Okay, these questions are very interesting. So when I was at Nortel, I ran field support for the U.S. And every day I had to call about 20 customers at 8 a.m. just to let them know how the main question would be, how's my network doing? How's our applications running? Is there any issue? Is there any problem? And interestingly, about 2 years ago, I was talking to somebody who was a network operations director. He asked me the same questions. So really, nothing has changed from how's my network operating. It still remains the same. We all know if a network is slow or down, man, what the hell is going on? Why is it? What's the problem? These are standard questions, happens every day, and this is what we're addressing. So want to come up, show you what we do. So if you look at this map here, this picture over here, you got all these applications on the left side. Okay, it goes AR, VR. It's automotive. You know, one of the problems Tesla has actually, for example, is that if you're stuck on I-95, for example, as it happened to my cousin, he had to wait 2 hours for somebody to come and tow the car to a Tesla shop. There's no, they don't have any real-time access to information. It has to be towed into the shop. So one of the things that we have, exactly right, Kay, there's no other way to do it. They don't know. And
do constant communications with them all day long.
the thing is that he had to get towed, actually.
I guess depending on the fish. I'm sorry.
Yeah.
If you have a flat tire,
No,
you have to be
because
towed
it
to the
breaks
shop.
the battery down.
You had to take it to the shop. My wife's boss has a Tesla S model. She bought it a year ago. It has all kinds of problems. She's calling somebody from Tesla to come and look at it on a monthly basis. To the
John
point,
Deere has that same problem. If you need another customer.
yeah. So the main thing is that is how do you get that information into a network area, and that's really a key factor to get that in real time, right? I mean, the biggest problem I find with the check engine light is I don't need to know. Tell me what the problem is. I mean, don't just leave it there dangling. So we sit in the middle. We collect data from all the communication that happens, and it's called DART. It's that we call it, and it's a data analytics in real time. We collect all the information. We have underpinning ML technology that's time series based. We pull the data in, and we can analyze that in real time and present that. And we're integrated with AWS, and Bill leads that show and all that. With AWS, Microsoft Azure, and GCP, all our projects are related to working with them because that's what the customers are looking for. And I'll say this, that Microsoft Azure, because they're sliding Azure under the 365 pricing, it's becoming a little more prevalent than AWS. And AWS has got its market share dropping because of that. Because Azure is climbing up and getting some market share, but it's because of the 365 component being make it easy for the Azure to be gaining traction over there. And so we are working. So one of the key thing is the latency factor, and it's so huge today with 5G and the edge computing. It's probably the leading issue that everybody talks about. And we are in projects today where you got the core is Microsoft, the radio is somebody else, and they'll tell us you guys are the main people in this because the thing that they're concerned about is what's the connectivity? Can I know things in real time and make sure that latency is meeting SLA? And that's the key factor there. And there's just one other thing. I'll pick up the next slide on here. Just about the use cases. So these are live projects that are going on with us right now. Healthcare, very interesting. I didn't even think about this, but they are this company. This is an instrumentation company in healthcare that has got equipment in the operating theater, and they're right now using wireline or Wi-Fi wired, right? And they don't want to do that, and so they want to use mobile devices off 5G, and they want to use the edge computing for that purpose. So. And the biggest concern is again latency because now it's in the operating theater. So how do they make sure that this thing is going to what they have is going to be working the way they have to be working all this while? So that's an example that we have. Logistics, the DHLs of the world, for example, are looking to monitor the packets coming off their trucks, right? And to be able to correlate that with what's happening on their automated warehouses. Making sure that all that is going to be running properly. It's a video monitoring there, but they want to make sure that happens in real time as well. Digital farms, this blew me away. They're looking to put chips, guys, in cows, okay? Just for health reasons. What's the soil going to be? What's the weather going to be? And this is coming out of the Midwest, and they're state-funded projects. So they're seriously looking into this in a very major way. And in fact, they're looking at buying a lot of mass land, up to about 80 to 100 cell towers over 300 square miles, and then how do you monitor that? So that's what they're looking at, the massive area problem. The manufacturing, of course, is robots, the logistics issues that we've been finding out on the supply chain side, how do you move packets, etc. And smart cities. We were here for an IoT presentation, right, about a few months ago, with the trackers on the road. How is that going to be monitored, right? It's something we had conversations with them as well about how do you take that and make that better in getting information in real time, correlating what the traffic is, not just traffic. Can I adjust the traffic lanes accordingly depending on what the traffic is going to be? For example, so some of those things are happening. But these are some projects that we're looking at, and the thing that we are also seeing is that everybody talks 5G, but until this year there were no 5G devices available, enabled. I'm not sure they're still there. It's still in the works. But I think this is going to be a bigger play around next year. But people are beginning to test it out locally within their areas to see how to make sure they're ready for what's going to happen. So we are focused in 3 areas really. I don't know if you can read this, but SLAs, telcos, for example, are extremely concerned about their SLA. Okay, they want that SLA to be not. Yes, it's got to be there. So we're really focused on that, and that's why the thing that it's not just latency. We can tell you a location of a problem as soon as it happens. I had Verizon tell me about 4 years ago, they had a problem in Houston. They couldn't identify what the problem was. And they said, hey, quote unquote, just tell us where it is and we'll take it from there. That in itself will be golden. And they could not figure it out. So right now, if you have Cirries in the network, we're like an MRI into the network that we're tapped into, and there's a problem, you can be traveling anywhere in the world, you will get a ping that you got a problem. And the location, I will even tell you what caused it. Because all of them are fundamentally running either Cisco or Juniper gear, which is pretty standard in what the causes are going to be. So we have actually triangulated all that information and present that and tell you what it is. So what happens today is a lot of the money that goes in is going into discovery. Discovery is 95% of the cost of where the problem is. Then it's a lot less after that to resolve it. So we really reduce MTTR. That's where we put the SLA.
Do you want us to hold questions, or do you want to take them as you go? Or
you can ask the question. No problem.
One of the things that I'm sure you guys are dealing with, and if you can talk about it at a high level, is that you're talking about alerts, notifications, whatever. Is this massive amount of alerts that are out there of varying degrees, and the ability? You guys must have some capability, obviously, to sort through those, to determine what's a warning, what's a critical, and stuff like that. And that's got to be a massive amount of data to manage.
Yeah, we do. I'll let Bill answer that as well.
Yeah. Well, we have flexible alert builders for one of the things we do is we collect syslogs from all sorts of devices, and we've got an alert builder for analyzing the syslog messages and deciding, okay, what level of alert do we really want this to be at? We can do some time filtering on it, that sort of thing. Filter with some other, with a number of keyword capabilities, and then once we trigger an alert, we can specify. We also have a custom workflow capability as well. So alerts can trigger custom workflows, which we use a couple of different ways currently, but there's probably lots of ways we could use it. One is just working through notifications. Another is suggesting a hierarchy of repair procedures, and a third is use it to implement custom APIs to other control systems, because we know we're a small company. We're a piece of generally a much bigger AI ops setup or whatever else. So we can match APIs into those AI ops.
Go ahead, Tom.
How does the evolution of ORAN affect what you're doing?
ORAN is, I mean, we're not directly tied to ORAN,
Right, I understand.
but ORAN, we can, we typically work at the with the user plane. Okay, so, and looking at user plane packets. Okay, and the experience that packet payload gets to, but we can also take in alerts, ORAN generated alerts like SysLogs or whatever else, and process those as we do in any other device.
Well, I would think that your technology would take advantage, would provide an advantage to ORAN. So
You would. The thing,
the ORAN players all are trying to get some kind of edge in the various open pieces that they provide. We looked at one time. We're not a big company. We can't do everything. We just didn't see the ORAN technology and market coalescing as quick as we would need it to be before we got in. So we looked at doing some work in the near real-time brick arena and that kind of stuff, and we may still do that as things mature a little bit.
Are you doing any proactive, say, AI to determine if there's modules that are failing?
AI is, we started off with AI just looking at packet delivery patterns and envelopes, and that's where that's closest to what we do best. And when I talk about AI ops, lots of people are big in that, and people have their solutions, and so that's where we've worked on custom APIs and filtering of inputs to those systems. We can get into that, but like I said, we're a small player, and we focus on what we do best, and help work with the other players that are stronger. But for us, things like looking at the packet delivery envelopes, we use some machine learning in that regard, and that's where we fit. You got to remember, these days all the packets are encrypted, and the old deep packet inspection that we all heard about, it was big 10 years ago. You can't get in there to look. It's encrypted, so you've got to deduce certain things by looking at the handshake envelopes and that kind of stuff. So we're using machine learning in that regard.
So are you able to actually look down at, I want to say CRC, if that makes sense? It's been a while, but effectively see if there's bits that are recorrecting themselves? Transmission, are you getting at that level?
No, we're not down at that level. I mean, CRC and that kind of stuff would be at the TLC layer, where we see the network layer.
okay. The one thing I want to address here is enhanced network security. There's 100,000 security players out there. They can't stop a ransomware problem. And really one of the fundamental problems that the security guys have in security in general is that the telltale signs are actually in the network. And you need a network performance engine on the front end to identify what the traffic is and investigate that, because that's where the clues are going to be. I had an instance one time at Capital One a few years ago. I was working somewhere else, and they were getting DDoS at 200 kilobits per second, well below radar, below 1200 baud, and it built up where they got hit really hard, and we then collected 30 terabytes and 32 terabytes of data, and our chief architect found out the problem in about 40 minutes. We backtracked to the Middle East. So that's what's happening. So some of the things that you see happening in ransomware is precisely because of that. And they had a technology that was Windows-based and just could not do the kind of thing that we were doing. And so the Secret Service called us in to help them out, because we had done a separate project with another case along with that was security related as well. But just to let you know the kind of problems that these security tools are not addressing, and they only know after a breach has occurred. They can't do a pre-breach because they don't have the knowledge to be able to do that, and that's something we address. So we're not in security business, but if you don't have something that like what we have to see what that looks like Bill talked about the envelopes look like on the traffic side, you can't investigate an anomaly that's coming in, and that's where the issues crop up. So that's just one of the
Have you talked to City of Dallas? They're still not up after
Horse, barn,
5 weeks
door, you know.
of ransomware. City of Dallas is still not functioning properly
still not functioning.
after 5 weeks of the ransomware.
And we should have a discussion on that.
Yeah.
We'll talk about
Well, yeah, that's all I know is the news part. I don't have connections. But
Yeah,
it's just
no,
pathetic.
but so they're still underwater. Wow. So the key thing here is, we'll run through this quickly here, but we get to is that, as Bill talked about, we collect 100% of the packets. If you don't collect 100% of the packets, you don't have a proper forensics on what's happening, the performance, or any data that we ship out to a security tool out there. So that's what we do, 100% of the packet. And then one of the problems that you see a lot of tools have out there, they do sampling data of logs. The problem with sampling is it collects it in time frames like this, it's chunks. But what happens if you miss something in the middle and you don't have that? That's the one that you need to have a problem. And that's why the sampling doesn't work properly. And it does a massive hole. And that's where the gaps come in. That's what you really do need the packets to collect that. And we run completely in software. It runs up in the cloud. If somebody wants a hardware problem on the wire, we can do that as well. But it's a lot more cost effective to run this in the cloud, because that's where everything is operating right now. Okay, and that's what we do. So we collect all what we talk.
Now, let me point out that maybe you get the impression it's all running in the public cloud. Actually, we're doing a lot of the work in private clouds right now, although we do have offering in the public cloud.
Real quick, so we collect all the data that's in the network, whether that's SNMP flow data, it could be anybody's flow data as well, and raw packets. And we have packet sensors and meta sensors that then pipe the information to our analytics engine that presents the whole thing in real time. And we can take the data that we have, and that's come up, in fact, very recently came up. Somebody is using a router that is manufactured in Latvia, but they don't do some functions that this company wants to do, and they're based out of Singapore. And they asked us if we could help with them with that. So we're kind of going through that issue of how to create flow packets for them. If they give us access to the switching side, then we can give them the information that they want. But some of the things that happen, and this is the kind of thing that we do. So we can send information to any tool out there that's doing security as well from the information that we provide.
Interesting. MikroTik?
Huh?
I was going to say Latvia. Was it MikroTik or somebody? Okay.
Good one, Chris.
I know my stuff. But yeah.
Sure Across Asia, they're using that a lot because it's low in cost.
I love it. I use them personally. I personally use it.
Okay, the one thing that's missing is the flow component.
Correct. Their OAM is not
very good.
not
So
very
what we
good.
said to this company, I think, was that we can get the, as Bill said, doing this. Do they have port mirroring?
Yes, but you have to program it manually in many
So
cases.
it's something we should have.
Yeah. It's got all the capabilities, but you have to
Figure it out.
do it yourself in a lot of cases.
Okay.
Like a lot of people like me, they're tinkerers, love them because you can configure them to do the interesting things.
If you can do the port mirroring, then I think we can come up with something.
You have to program that in, but yeah,
So that's what we like,
there's a scripting interface, but you would have to.
manually do it.
Mhm. It's not impossible.
Yeah.
Yeah, but it's an interesting product for sure because the OAM is horrible. The configuration is awesome. The OAM is not good.
But good one. Just to quickly, these are the metrics that we collect, about 7, 8 of them. Within each of them, there's 15 other sub-metrics. So we provide all this information, and Roger will run through it, what the landing page would look like, which is this. So anybody logging in, this is the landing page. How's the network doing? That's where this is coming from. So as soon as you log in, you know exactly what's happening. So that's what it is. So that's all I have. This is any questions?
This would work for a PCN application too, right? A private cellular network. So like all the PCNs that are going to, that are all the campuses that are going to PCNs, and
That's probably where most of the projects are right now.
okay.
What's the, I used to be in telecom, and what's, you were with Nortel, and, they went to Gen Band and then Ribbon, and can you give like a high level perspective? What's happening with, you had a huge Nortel switch, then you had a soft switch from Gen Band, and Ribbon still has soft switches out there, but what's the evolution of that you see? Is it going to the cloud? Is it, you get like a quick perspective on that?
It is going to the cloud. That's the thing.
Yeah, I mean, most all the carriers are, their mobile networks drive everything. And then the major carriers also, have their own IP networks. And of course, it's everything over IP now. So somebody like a Verizon, they manage their IP backbone, and then all their enterprise products, their an ISP, both residential and enterprise, all that runs over it, and their wireless network is the big user. And it's a bigger and bigger user. Now you got, fixed wireless access, that comes from the mobile side that goes in and uses that network.
But eventually, I guess soft switch hardware product mounted in racks probably not going to be a product anymore, I would assume.
Well, yeah,
It's moving to software-defined networking. So you have a hardware.
there's a lot.
Yeah.
That's big.
Right, the hardware is only the server piece. Everything on software, just like Redmond's doing, right? I mean, got the message component, which is really the move up in the software. That's where they're operating on. It's interesting, right? You had a whole big DMS 100 PBX, and now it's like this.
Yeah.
It's
I was running a company, and we jumped from DMS 10 to a Gen Band.
Yeah.
And
Oh, yeah.
Amazing.
yeah. So the footprint is much smaller now.
Yeah.
There's more functionality, I think. And that's the direction it's going.
And then Microsoft, they bought Metaswitch
They bought
a few
Metaswitch,
years ago.
Yeah.
Yeah.
That's the Azure control component in 5G.
The core.
The core. So that's what we're integrated with. So we are finding that in the enterprise IoT 5G, we're seeing more of that than AWS's wavelength or GCP. So that's the battle that's happening in the neck between the three of them. I know Oracle is trying to squeeze in there, but I don't think they have a shot at it. The big three is really going to control that.
Microsoft, Azure, and
And Google.
AWS, and Google, you think is that the
Yeah.
third?
Yeah.
They're too far ahead.
Yeah, they've all got appliances of some sort that are private, that they can actually put in on premise at the enterprise. But they've extended the control and management of it to the public cloud, so that you manage your instances the same, whether they're in the public cloud or in the private. They're really big on that. They're pushing that.
Yeah, they all run on the hardware side. We are seeing Dell as the key component of the server more than HP. So we're seeing that as well.
Interesting.
If you stop sharing,
Yeah.
because we want to see the demo. All right, Roger.
Okay, can you see that now?
Okay, can you see that now?
Yeah, I'm gonna fix it just a bit. It's down pretty far.
Okay, so
Can you
this
hear
is
us?
Okay, so
this is the landing page.
this is
you
the
see
landing page you
when you
see
sign on.
when you sign
because
on.
Customers have asked us for
Customers have
one
asked
pane
us
of
for
glass
one
overview of the network status.
Network status.
So on the left, you have
On
a
the
summary
have a
of the
summary
network, which includes infrastructure, traffic metrics, and network performance. In the network performance metrics, items in green are within parameter. Those in yellow are approaching alert levels. And those in red have exceeded the alert levels, which is the same nomenclature we use throughout. On the right, the map, you can zoom in and out to see the locations. This is our test demo structure. And we have 6 locations and 11 routes. I'm going to show you some tabs starting at the top, going to the right, and then on the left going down. So you can see on the map that the Dallas location is red. So I'm going to click on it. And I get details on the routers in that location. I see the Cisco 603 router is red. So I click on it. I see a picture of the router. I see the interfaces. I see the memory usage. And you can see this large peak here is what caused the alarm. I see the CPU usage and the link usage. When I get the link usage, I can scroll across the chart, and the values represented in an overlay window. I can also click in the items in the legend. So if I click once, that item disappears. If I click twice, all the other items disappear. And that's the same in all the charts and the Dart system. So that was an overview of the inventory map and router management. So let's look at the network entities tab. This associates an IP address, a device name, and a group name, which allows you to name each network for analytics and group them for syslog records. You can add a new one by hitting the plus sign at the top right, and or edit an existing one by hitting the pencil icon next to the entity. Next, we have devices. The device tab shows all the devices connected to the system. Has the ID, the location, the device name, the vendor, the model, the usage, the serial number, asset ID, and status. Any questions so far?
Not yet.
Okay. If you click on the information icon, you get a summary, you get interfaces, and inventory information. Okay, on the networks tab, details of the network, the ID, name, type, and IP range. On the locations tab, list all the locations, names, addresses, and coordinates. On the auto discovery tab, you can do a ping sweep, a port scan, SNMP discovery. Then in scan history, you can schedule tasks. You can see we have two task schedules. Both of them are ping sweep, one daily and one week. Okay, on the home icon. Oops. We have the same traffic summary as a landing page on the left, but now you have a chart on the right and many more charts below. So top 10 sources, top 10 protocols, top 10 destination, top 10 applications, out of order packets, and highest jitter. Good. Along with several more. At the bottom, you see sliding scale. You can slide the bar and change what you're looking at. And if that's not enough, you can hit the gear wheel. You put in a lower and upper limit, then save, and you'll see exactly what happened at that time. On the alarms tab, you can look at severity that you want to see. On the syslog tab, shows the alert details on the landing page. If you click on alerts at the top, and scroll to overview, you will see a summary on the left, alert severity on the right, and alert history below. If you click on events and overview, you'll see traffic by host, top syslog, top syslog host, top syslog groups, and traffic summary. On the data exploration tab, you can see details analysis of flows and packets. So the landing page is flow analyzer, and clicking on packet viewer brings up the packet data. You can click on the check mark at the top right. Then you can select packets, and then you can click on the export icon to export the files to a PCAP. On the network analysis tab, a lot of predefined charts. The first one is for applications. So you have all of these in here. New charts can be added by hitting the plus sign, picking the type of chart that you want, and then dragging it on the palette. If I go to the bottom, there's my new chart. Okay. And I click on the gear wheel.
Yeah, scroll down further.
Scroll down.
Yeah, the new chart should have been way down at the bottom.
I got it right here.
Okay.
It's on.
Now let me show you the automation. First thing you see is the alert rule builder that Bill was talking about. We have several rules already built in. You can modify these and add new alerts. If you click on the sign at the top right, you can add a new alert. If we go back to the alert rule builder, notice that the alert handler is a workflow. Workflows, as Bill has stated, is our most competitive advantage. It does all the invocation of an alert that is usually done manually and suggests action for resolution, reducing MTTR and manpower requirement. Now let's look at workflow. On the left, you have filter nodes. Our coder programs to perform certain functions. For example, if I hover over the inject filter node, you see a description of what it does. That means you can create a workflow on the palette without having to do any programming. You can also create a workflow to define an API connection. You can see that we have already created workflows for out-of-order packets, congestion, network latency, application latency, and jitter. On the palette, you double-click on any item, and the menu displays the properties of that node. So if I click on send mail at the top, and then I double-click on the send mail, I see where you can add email address. If you want to add another workflow, Again, you hit the plus sign on the right. You get a blank palette. You can grab the items you want and connect them. So workflows automatically investigate an alarm and sends an email explaining the problem encountered, the most probable cause, and the best solution. This means reduce MTTR and frees up resources that normally would investigate alarms manually. If you click on the Systems tab and look at the top on Notification Settings, the drop-down menu explains adding support engineers and support groups for alarms. If you click on User Management, you can define users and their role. And obviously, the plus sign on the right can add new users. So that concludes the Dart demo. 4 things to remember. Dart is real-time, 100% packet capture. It's software only. It's 5G edge capable. And 80% of remediation time is finding a problem, and workflows automate the process. Thank you.
Yeah.
Okay.
Anybody want to see any more of those?
If you could go back to the workflow editor, because that's really where your meat and potatoes of your value is, right?
Yep.
So
A lot of flexibility.
yeah, so this is where you define your SLAs, and this is what's really slick.
Well, the SLAs
I mean, but you know,
are part here and part actually in the alert builder.
yeah, exactly. But this where you can kind of define your metrics.
So and yeah, we use this for yeah. I mean the alerts have metrics. You can do some further filtering on those here.
But you're doing your business logic largely here,
yeah,
right?
You know, as I said, custom API implementation. We use these tools. And it's just visual programming. That's those of us in the old days that work with service creation environments.
Yeah,
it looks very familiar, right? That's that's what it is. But there's a lot of different little toolboxes up there. And I'm not sure this demonstration package has some of the ones we put in there. We can use it to create SNMP traps, for example. So that somebody else they've got an existing net cool system or something like that. And they want to.
You can get in there and
so we build that interface here. We had another AIOps outfit had a JSON interface that they wanted. Well,
isn't this all JSON objects behind the scenes?
We can build it with this because that's the input to this is JSON objects.
Yeah.
It's kind of nice.
But you're right. This is unique. We have found out that the other players don't have
No,
not just the depth, but the ability to when something happens, hey, can I know right off the bat?
because I've seen some of the other tools on the market. This is kind of nice compared to the other guys. This is what stands out, I think.
A lot of flexibility.
A lot of them will have really fancy looking dashboards and stuff, but it's really this SLA business logic that pays the bills, right?
It's more engineer. It's definitely more engineer based, right? It speaks that language. It's very simple. You hit on something. The other guys, you guys have a really niche market. Can you talk a little bit about your marketing strategy, like your target, your shows, like how do you guys take this to market? Is it primarily tier 1 carriers?
No, we're really working with partners with the systems integrators, or anybody else who's willing to partner with us. And that's the best, that's how we do it on all of our go-to-market is with the SaaS, right? Or anybody else who's a small company who can't scale that with that level of. Now, are the telcos our primary target? Not necessarily, because let's take an example of farming. The telcos are not involved in it. And one of the things that we have found out is that all the CVRS is a spectrum out there. They can't handle telco ways of doing things. They're just not. We found that out as well. So, but typically, telcos are a big base from a network standpoint, but the end customer gets owned by the partner.
So they want to, all the major telcos want to be a player in the enterprise, and they're trying to figure out how that's going to work. But meanwhile, while they're figuring that out, I mean, there's a few hundred major enterprises that have 5G projects going on. Nokia's, I think, is probably one of the leaders. They've in addressing that segment.
That's the conversation, Joe, we have had in the past, right?
Mm-hmm.
That's the model.
Yeah, you're just curious with Justin and your.
Yeah, this is a lot more lightweight. The only other tool I've ever seen do this is like ServiceNow, which is way more expensive than your tool, right?
Yeah. And the other thing we have going for us is we're a small, yet nimble company. We've built out a number of tools that are general purpose, so we're able to configure things and set things up to match specific situations. If in some of these projects, if somebody says, "Hey, we got to see this. We got to have this visibility." I'm head of product management, but I can tell you, I've done that, and for Nortel and stuff. And it's not like, well, I'll bring it to my feature priority committee, and we'll see where it slots in, and we got this, that, and the other release. We're much easier to work with when we see something that is going to add value, across the board. We'll look at delivering something, pretty quickly. So that's the other thing we really bring to the table.
That's the BCS process, like.
Mm-hmm. Yeah.
All right, if nothing else, then, guys, thank you, Bill. Thank you, Roger, for the demonstration. I really appreciate it.
Okay, no problem. It was fun. It's fun.
Oh, great. Thank you.